Good morning, good afternoon, good evening. Depending on what time you check this video out, let's talk about functions, domain, and a little bit of range. Let's get it going. Okay. So welcome. Let's get this started. So today we're going to talk about functions, and let me get my glasses here, and domain and range. So this idea that relations have inputs and outputs, all right? Let's remind ourselves that relations have inputs and outputs. If we were thinking about a coordinate plane, we would think about, right, our x values, right, our x, the values that fall on the x-axis versus the outputs, or the y, right, the values that fall on the y-axis. So this idea of inputs and outputs, and that a relation, right, we've been talking about this, a relation is a set of inputs and outputs, but not all relations are a function. Right, so let's go through a couple of exercises to remind ourselves what we're talking about in terms of functionality. Functions, right? So for every input, there should be an output. For every input, there should be a unique output. There should never be an opportunity where, so it's not a function if the input has more than one output. So for example, my birthday's in June. That's when my birthday is, right? I can't have a birthday in June and have another birthday in November. It doesn't work that way. So the input has to have a unique output. Now, on the flip side of that scenario, right? You and I, we can have the same birthday. So if you think of yourself, excuse me, in terms of excuse me, in terms of an input, right? You're an input, I'm an input. And can we have the same birthday? Yeah, so we can have the same output, right? Even though we are two inputs. So you just can't have the two different birthdays, right? I just can't have two different birthdays, but we can have the same one. So let's take a look at some variants here on inputs and outputs, domain and range. So if we look at A, B, C, D here, right? Let's start with A. We see all of our inputs here. And there is some function, some equation that we haven't talked about, but we don't need to. Let's just concentrate on this idea of functions. So if I look at all my inputs, do they all have different outputs? Yeah. Since all my inputs are different, all my outputs are different, it's a function. Ta-da! That's it. That's all the evidence you need. Let's look at B. Again, okay, all the inputs are different, all the outputs are such. Yep, this is a function. Take a look at C. I'm wondering what you're thinking for C here. If you said this is not a function, you would be absolutely correct, right? Because look at those two inputs. Here I said when I input 1, I get out 10. So that has to mean whenever I see 1 later on my input list, it should always say 10, but it says 7. So this C is not a function. D is just another way that I could write this, right? I could give it to you. I give you ordered pairs or give you your input outputs like this in a table, or I can give it to you as ordered pairs, but it still applies, right? Our X values here, these are our inputs, and the Y coordinates would be our outputs. And if we look at those, is this a function? And the answer is it is not. So even when you look at these two, right? So -3 and 2 have the same output, and that can happen, right? They can have the same birthdays, but check this out. 6 comma 7, 6 comma 2. Nope. Not a function. So while we're on this page, right, we could talk domain and range here in the scenarios, and in this in these scenarios, I could give you, or I could ask for the domain and range, and here's where you have a finite, a limited number of domain values, of range values. So simply, let's remind ourselves, if I asked you for all the domain of A, you would tell me -2, -1, 0, 1, and 2. And if I asked for the range, you would say 5, 7, 6, and 8, right? You would not repeat the 5. Now, and then the same thing here, right? What's the domain here? 5, 7, 9, 10. What's the range? 10, 5, 6, 4. Similarly here, even though we established that C is not a function, right? Your inputs or your domain is just 0, 1, and 2. Don't repeat numbers unnecessarily. And then the range 10, 5, 7, 8. Let's look at a couple other scenarios. If I gave you something that looked like this, could this be a function? Okay, let's take a look. Look at my inputs. Look at my outputs. Is this a function? Absolutely. Yep, it's a function. Here's your domain. Here's your range. All right, let's look at another scenario. Here I just shortened it to letters, but it's the same fruit. But even if so, let's just look at the letters. Same thing. Do you see, is this a function? You notice here they have S and O have same outputs. Is that a function? Yes, it is. Remember, we can have the same outputs. Yes, that's actually absolutely correct. And then the last one here before we take a look at some graphs. Is this a function? No, it is not, because if you look at P here for pairs, right, P is going to 7 and it is going to 10. That cannot happen. That cannot happen at all. Even though banana and orange both point to 12, that is okay. That is not okay. And again, our domain, this would be our domain, this would be our range. Let's take a look at a few graphs, shall we? Where we talk domain and range. Domain we know refers to all the X values, the input, and Y, okay? So we've been looking at this. We're gonna take just a quick look at a few of these, and then we're gonna wrap it, because I think you pretty much have it. So if I was looking at the domain of, say, a line like this, right, I wanna look at all the values that are affected on X. So that arrow lets me know that this line is going in that direction continually. But even though it is going on that angle, it is still increasing on X, right? When I come to an X value, I can go up, I can get to a point. I keep going on this X axis. I go up, there's another point. So it just keeps increasing on X. But also if I come to the negative side of X, I come to a negative value and go down, there's more there. So what is my domain, friends, of this? All my X values? You got it. It would be negative infinity to infinity. And then conversely, what is happening on the Y, even though it's on an angle, is it still going up? Yeah. And even though it's on an angle, is this arrow still pointing down? Absolutely. So my range for the first one here is also negative infinity to infinity. Almost done here. How about this? Ooh, how about this parabola here? Domain, what is happening to my X values? Okay, let's check it out. So on X here, even though it is curving out like this. Here we go. So since it's curving out like this, it is reaching up, but it's still reaching negative. So I'm going from negative infinity to infinity. Let's be careful, though, talking about that range, right? When we're thinking about the Y, what's happening with the Y? Well, we know that the arrows are pointing to infinity, and they come down to 0. So that means my range is going to be 0 to infinity for number 2. I think you're starting to see how it locks on in certain positions. Okay. Last one, and then we're done. You've all been great. So let's look at this third one here. Domain here. What is happening on my X? Okay, on my X, I see that I'm at 1. The arrows let me know I'm going towards infinity. So my domain is 1 to infinity. And then my range, because even though it's curving, it's still going up. It's curving, it's still going down. Okay, that would be negative infinity to infinity. Now, you know what? Let's throw in one more. We'll throw in one more and then that's it. That's it. That's it. So let's say let's look at this graph here. Let's say I could sketch it real quick, y'all, because I want to let y'all go. And I did something like this. What's that domain? What is domain of just that straight line? Right? Well, we know domain represents all of our x values, our inputs. So we're going from, you got it, negative infinity to infinity. And if the range is talking about the change of y, well, this line sits right at 2. It doesn't go away from 2. It doesn't go above 2. So the only place you find this line is 2. All right. I just want to give you an overview of what's happening with domain and range, how we find domain and range when we're looking at when we have finite values, when we're looking at numbers that we can actually count, we can write down, versus something like a graph that gives us an infinite amount of values. All right. So take a look at homework number 7 again. Let's review that, ask any questions, and that should do it. So hopefully that helped. And if not, come see me. Have a good one.